All right, so if you're a backend architect working in the AI space, you already know the ground is just constantly shifting under your feet, right? So today, we're going to tackle a really critical topic. How do you actually build AI systems that can survive what's coming next? Systems that are resilient, smart, and genuinely future-proof.
Okay, I'm sure this hits close to home for anyone who's actually built with an LLM. You're in the zone, right? You're deep into a complex problem, you're building something cool, and then poof. The context just vanishes. This quote from a dev on Reddit, it just perfectly captures that feeling, that deep frustration. The AI that was your genius co-pilot a second ago, yeah, it's got total amnesia now. And look, this isn't just some small bug, right? It's not a minor annoyance. As this other user says, it's a huge problem. It completely torpedoes your workflow. And this technical headache, this memory loss, it's actually a symptom of a much, much bigger strategic issue. It's something every single architect needs to have on their radar, like yesterday. So what is that problem? Well, it's the classic vendor lock-in nightmare. Think about it. When you build your entire application, your entire product, on top of one company's API, you're not just using their service, you are chaining your company's future to their roadmap. You're basically handing over the keys. So let me ask you, seriously, what's your game plan? What happens tomorrow if your main AI provider decides to, I don't know, 10x their prices? Or what if that one specific model version that your entire product depends on just gets deprecated? For most teams, the answer is a nightmare. We're talking a frantic, expensive, all-hands-on-deck rewrite of your entire codebase. You're not innovating, you're just reacting. And that's the bottom line, isn't it? Your product, your innovation, even how fast you can ship, it's all held hostage by a company whose roadmap you have zero control over. From an architectural standpoint, that's just brittle. It's a huge business risk, and frankly, it's the kind of risk we get paid to mitigate. And this whole mess, it loops right back to that technical frustration we saw at the beginning. So let's dive into why these AIs forget things, this memory void. The real reason models freak out, like that Reddit user said, is pretty simple. By design, their APIs are stateless. That means every single API call is a completely fresh start. It's like talking to someone with no short-term memory. The model literally has no idea what you said 5 seconds ago. So you basically have two ways to handle this. The standard way, with a stateless API, is a real pain. You, the developer, have to manually keep track of the entire conversation history and then cram it all back into the context window with every single new message. It's slow, it gets expensive fast, and it's super easy to mess up. Now, compare that to a stateful approach. Here you have a smart layer, a middleware that remembers the context for you. You just send the new message. That's it. It handles all the heavy lifting. And this is where a really powerful new architectural pattern starts to emerge, the AI router. Specifically, we're going to look at a platform called Backboard because it's built from the ground up to solve both of these massive problems, the vendor lock-in and the memory void, with the single really elegant solution. So what exactly is an AI routing layer? The best way to think about it is like an air traffic controller for your AI stack. It's this one single API that sits between your app and the, let's be honest, chaotic mess of different AI models out there. It becomes your central command center, giving you total control over everything, which model to use for which task, how to manage memory, and even how to pull in external data. And this right here is the killer feature, the real strategic value. This layer is, for all intents and purposes, the insurance policy for your entire AI stack. Your main provider suddenly goes down or changes their terms, you don't panic. You don't launch a massive refactoring project. You just change one line in a config file to route traffic to a different model. And your app, it just keeps working. It's that simple. Okay, so what does having this total control actually look like in the real world? Let's get into the specifics of how one API can give you this kind of power and flexibility. Yeah, that number. Over 2,200. That's a number that should make any architect just stop and think for a second. We're talking about access to more than 2,200 different language models, all through one single API integration. And this isn't about just picking one and sticking with it. It's about having the freedom to use the absolute best model for any specific task without the nightmare of a new integration every single time.
And when we say access, we mean access to pretty much the whole landscape. You've got your OpenAI models, you've got Anthropic's entire Claude family, Google's Gemini. You can even tap into high-performance models from places like Cerebras and get access to the entire massive open router network. You can A/B test them, you can benchmark them, you can swap them in and out of production instantly. But here's the real magic. This is the part that ties this whole strategy together. It's what's called portable memory. See, because the routing layer is managing the conversation state, the context, the memory, is no longer locked to one specific model. This is huge. It means you can start a conversation with, say, GPT-4, then switch over to Claude 3 for a follow-up, and then maybe use a Gemini model to summarize the whole thing, and the AI never skips a beat. The context just follows you from model to model. It's a total game changer. And look, this isn't just some marketing fluff. They've actually benchmarked this. On the LocoMOM AI memory test, which is the industry standard for this stuff, Backboard's memory system hits over 90% accuracy. Now, compare that to just using the standard OpenAI API out of the box, which is barely breaking 50%. That's not a small improvement. That's a fundamentally smarter and more reliable way to build. So let's just boil this all down. Your entire complex AI stack suddenly gets a lot simpler. It really comes down to three things. First, stateful memory. It's just done for you. You don't have to worry about it. Second, model flexibility. You can instantly swap between thousands of models. And third, and this is a big one for architects, it has built-in RAG, or Retrieval Augmented Generation. What that means is you don't have to stand up a whole separate vector database and build your own retrieval pipeline. It's just part of the platform. It's all handled for you. So let's tie this all back to where we started. All of these features, the model switching, that portable memory, the built-in RAG, these aren't just a collection of cool tech demos. For an architect, these are critical strategic choices you make to truly future-proof your entire system. I love this quote from a head of engineering because it just nails it. You have something a lot of people don't know they will desperately need very soon. This says it all, really. An AI routing layer, it's not a nice-to-have feature anymore. With how fast this space is moving and fragmenting, this kind of strategic layer is quickly becoming an absolute necessity if you want to build anything serious and scalable.
So I'll just leave you with this one question to mull over about your own projects. Is your AI stack built just for today, functional, but ultimately brittle and locked in? Or are you architecting a system that's ready for tomorrow, one that's truly built to last, no matter what comes next? Something to think about. Thanks for watching.